Now that you somewhat understand what happens when these particles decay, we can talk about how long it takes for those particles to decay. And the way that we measure that is what's called the half-life. The half-life is the time that it takes for a given nuclide to undergo radioactive decay, or I'm sorry, the time that it takes for half of some amount of a given nuclide to undergo radioactive decay. For example, if you have 5 grams of tritium with a half-life of 12.3 years, then if you have that 5 grams of tritium and you wait 12.3 years, you would have left over 2.5 grams. Half of it will have decayed. Every 12.3 years after that, the amount would reduce by one half. So after 24 years, or about 25 years, you'd only have 1.25 grams remaining. After 3 half-lives, you'd be down to 0.625 grams. Notice that with each half-life, half of the substance still remains. So we're just continually cutting this thing in half. That means it takes a really, really long time until you get down to, 2 particles or 1 particle where you can no longer cut them in half. We can divide 6.2 or 0.625 grams by 2 a whole bunch of times before we get to a mass that is small enough to represent a single proton or a single neutron. Also notice that with each half-life, the amount that decays is less and less. Within the first half-life, we lost 2.5 grams. Right? The next time we only lost 1.25, and so on. So less and less decays over time. What this just means is that it takes a long, long time for a sample to fully decay. Metals, anything that you find that's radioactive, could possibly be radioactive for a really, really, really long time. In fact, a radioactive source is what's used to detect smoke in your smoke detector. And that radioactive source will last for almost the lifetime of the smoke detector, beyond all of the times that you change the batteries in it. And it's because it takes so long for that sample to deteriorate. This is just another way of looking at how radioactive half-lives occur. So let's say at time 0, we just start off with some amount of radium. The radium has a half-life of 1,600 years. So after 1,600 years, half of it is radium, and the rest is now the decay product, which is radon. After another 1,600 years, half of what's left over decays, leaving only this much radium, 1/4 left over. After that, half of the 1/4 decays, and you're left with 1/8. After another half-life, half of that would decay, leaving you with 1/16, and then 1/32 of your original amount. And that would just continue on until you got down to the point where you only had a few half-lives or a few atoms left. So let's say we have a 140 gram sample of potassium 40, and it's decayed, leaving only 35 grams after 25 days. We want to know what's the half-life. Well, we can determine the amount that has decayed 140 grams. Well, let's look at this a different way. I think this will be easier for you guys to understand. If we start off with our original amount and we divide it by 2, right, so for 1 half-life, we're now left with 70 grams. After the second half-life, well, now we're left with 35 grams. 2 half-lives have passed, which means that if we take our time and divide it by 2, we find that there are 12.5 days for every half-life. So after 12.5 days, it decayed from 140 to 70, and after the next 12.5 days, it decayed from 70 to 35.